Hey guys, so today we're going to go over inverse functions a little more. This time we're going to be dealing with a log function. So starting off, we're just going to take the function given. Instead of f of x, I'm just going to write y equals log base 5 of x minus 1 plus 6. So as shown in the intro for inverse functions, the first step is you're just going to switch x and y. Everything else will stay the same, and then from here, we'll just work on getting y by itself. Okay, so the y minus 1 does belong to the log base 5, but the 6 is just being added outside of it, so we can move the 6 to both sides of the equal sign first to get rid of it, and that'll be x minus 6, because they're not like terms, we bring them both down, equals log base 5 of y minus 1. So the thing is, the y minus 1, I can't get it by itself because it belongs to the log base of 5. So I'd have to actually get rid of the log base of 5 first. Again, remember the way to get rid of a log base is to give it an exponential base of the same value. So whatever I do to one side, I'm going to do to the other. Now, mind you, this is an exponential base, so now everything else is now an exponent. So this becomes 5 to the x minus 6 power equals log base 5 exponential base 5. They're gone, leaving you with y minus 1, because if you don't have an exponential base, you no longer have an exponent. So this is just y minus 1 by itself, and to get y by itself, we're going to add 1 to both sides. And keep in mind that you are just adding 1. It will not become an exponent in any way. So we have 5 to the x minus 6 power plus 1 equals y, which you can rewrite if you'd like to as 5 to the x minus 6 power plus 1 equals to the inverse function of x. So this would be your answer for the first part. Because from here, notice that the second part of the question asks, what is the domain of this inverse function? So remember, the domain are all the x values that x can be. Usually you will only see the restrictions in the rational functions because a fraction can't have a zero denominator, and in an even root because it has to be greater than or equal to 0 for you to take the even root of it, like a square root. You can't take the square root of a negative. We don't have either one of those here. So this is just an exponential function. I can replace x with a negative value and solve it. I could replace x with 0 and it'll still be fine, and I could replace x with a positive value and it would also still work. So we have no restrictions here, which means that the domain is all real numbers. I've kind of gotten the habit of setting it only to interval notation. So just as a reminder, in set notation, it's written as x such that x is an element of all real numbers. All right, guys, hope this helps.